expected. And that's what's fascinating, because you might not even have to build all this stuff. All you need is a box full of coil capacitors.
I would love to see this in a cryogenics lab, actually, but that's a separate topic.
So at any rate, so what we're talking about is electricity. Let me change colors here. Maybe this one will erase easier. I'm going to draw lighter. Okay, so let's come up with a dynamical situation that everybody can relate to, because they all drive. Everybody here drives an automobile, or has been in one. So what we're going to do is we're going to use that as our model. Okay, and we're going to analyze it dynamically, just as we would all these electrical things I'm talking about. Okay, so now what we decide to do, okay, is if we're moving at a speed, okay, and then all of a sudden we decide we're going to go to another speed. Okay, and then stop. Now all kinds of things happen when we do this. During this interval of time here, things happen that are measurable. Okay, now if the speed increases at a constant rate, what we get is we have a force pushing us, okay, which all of a sudden becomes a constant force, okay, pushing back. And then when the speed change is over and we're at a steady speed, this force disappears, and then there's no more perception of movement. Now another thing happens. If we measure the quantity of gasoline in the gas tank, okay, and when there's 100 cubic centimeters before we start, and there's 50 cubic centimeters after we execute this function, then not only do we have this wave in time, but now we have this little cube in space of gasoline that doesn't exist anymore. In other words, we have this force that appeared and disappeared, and we have 50 cubic centimeters of gasoline that went somewhere and is gone. Now this is what's called differentiation and integration. This is calculus. Okay, this is how Newton and Leibniz and these people, they wanted to find the relationships between these situations of why you have this integrated situation where you have the accumulation. In other words, the gasoline just doesn't disappear at once, but it accumulates or deaccumulates. In other words, it's an averaging process that weighs something that you can hold on to. Now we have this time differential here, which is kind of abstract. It's like only there when we're changing velocity, and then it's gone. So now if we take the weight of your body, okay, and we symbolize it by the Greek letter phi, okay, now we take this, you put a scale against your back in the seat, and we take that, okay, and we symbolize that by the Roman letter E. Okay, and we take this interval of time here, and we call that T. So this is the weight of your body. Okay, this is how much perpendicular weight there is pushing back on the seat. In other words, the reactionary weight, and this is the time in which this happens. Well, lo and behold, then we have a situation where we've analyzed algebraically what's going on with a very simple mathematical ratio. In other words, your weight as a ratio to the time involved in changing your velocity gives you a force E. Now what I can do without any changes at all is this Greek letter phi represents a quantity of magnetism. Okay, the time T represents the change in that quantity of magnetism, whether I'm turning the current up or I'm turning the current down or the magnet's moving or whatever. And that gives me what's called the electromotive force E. So now everybody here understands Faraday's law. It's that simple. So this is how electrodynamics and electromagnetism were created, was out of this simple relationship. If I have a quantity of magnetism and I vary it with respect to time, it gives me something appears, an electromotive force. Now this electromotive force then can be taken and applied to another situation, and then we can start to compound this stuff out. Now it turns out there's a pair of these equations in electricity because electricity is working in 2 dimensions. So we already know about magnetism. We know also electricity has to consist of what's called the dielectric or electrostatic field. So now we have 2 quantities. We not just have the weight quantity and the single process, but we have a pair of these things. Now if I take and use the Greek letter psi to represent the electrostatic field, and I vary that with respect to time, and give the rate change the letter I. Now not only do we have the electromotive force, but we have the current. So if I take a quantity of electricity, which I'll represent by the lower letter phi, it consists of two parts. Or it can't be electricity unless both parts are present. There's got to be a magnetic field, and there's got to be a dielectric field. And these are the two components. The magnetic field exists in electromagnetism in the dimension of space. In electromagnetism, the dielectric field exists in the dimension of counter space. So the electricity is always in one of these two dimensions. Okay, now if I take this quantity, the lowercase phi, then that becomes a symbolic representation of electricity. In other words, that is the ether in its electrified state. And it has dimensions. Because everything we're dealing with, there's dimensions. We have the dimensions of time. We have the dimensions of magnetism. These are what are called dimensions. So it turns out to be the dimensions of this are defined by something called Planck's constant. In other words, this quantity can only exist in integral multiples, which gives further justification to the lines of force theory, because the lines of force have definite size in some dimension. So the electricity can only exist in steps of these dimensions because electricity is made out of lines of force. So I can't have 1 and 4256 units of electrical induction, because it's got to be some kind of, how would you say, like a whole number. It's got to be in these steps, the whole number being Planck's constant. If we make that, a constant or a number, or just make it 1 in our equation. That's what Steinmetz did in order to make his 24-page equations into a little one-line algebraic relationship. All as Steinmetz did is, instead of giving the waves in a velocity, he gave light seconds. And once he used light seconds in the equations, instead of the normal lengths and times, but used that quantity, everything drops to drops to 1. Once that was unit value, then all these giant, the space-time continuum equations you were talking about, then all reduced to either the dimensions of space or time, and you didn't have to be stuck in both dimensions to do your calculations. And that was the only way that Steinmetz could represent these waves that were bouncing up and down the transmission lines, that there just didn't seem to be there's no way you could measure them or calculate them. It's like they were in another dimension. They were all trapped in these time dimensions and space dimensions, and it made them appear not to be there. So these two quantities we can derive, we break this down, electricity, into its two parts. Okay, now in electromagnetism, these two things have they have what's called a conjugate relationship, in that one is the denial of the other. And that's how one can be calculated from the other, and this is what gives us the Maxwell velocity of light situation. So if we take this electrical field, let's start to see what the electrical field looks like. We're going to start with electromagnetism because that's the one that everybody knows about, and that's what we're using, so there'll be no argument or mystery. Okay, what I have is I go out in the street and I look down there, and I see these two black wires up on the poles. Okay, the old 1800 municipal railway DC wires still run down this street that's Fulton here. Okay, so we're gonna see what's going on with these wires. Okay, there's 600 volts on these wires at 2,500 amps. Okay, which is kind of cranking. Those buses draw a lot of juice. So we're going to do, okay, these wires, they sit on these pieces of wood, which are referred to as insulators.
I'm sorry, how many volts is 20?
600. Wow. The feeders are 5,000 amps out of the rectifier. By the time they get here, it's probably more like 500. But if you look at the insulation all burned off, you can see that these things have been jammed up to about 2,500 amps. Okay, so what I have is I got a place that produces the electricity. Okay, I don't know where the rectifier stations are anymore. There's one back here down somewhere between Fulton and Geary, where the juice comes from. Okay, it's going down the road in between these poles to the buses, okay, that are down at the end of the street coming up here. And it produces all these kind of effects. Okay, what it is the wires are trapping the electricity so it can only go this way, only go down, up and down the line. Okay, it can't go over here or there or whatever. It's got to go one way. There is no electricity flowing in the wires whatsoever to speak of. It's non-existent. It's in the space between the wires. So now if we take these two conductors and we take a nice sideways chop so we don't have to look at the length, okay, we find that around these pieces of wire are circulations of ether. Okay, and one circulation is in one direction and one is in the other direction because we have a basically plus and minus type of transmission situation. This is called magnetism. Okay, and it's there. Everybody's held magnets and pushed them together and has felt this thing that's in between the magnets. The like poles is the best because you can feel like a jelly as you try to push them together. There's definitely something there, and it doesn't fall to the floor when you take the magnets away. So there's no mass. So what this does is it creates a concentration of magnetism in the space between the wires that predominantly moves vertically, okay, at right angles to the power flow. Now this magnetism physically pushes the wires apart. So in other words, when all the buses are running, the wires are going to be a little farther apart on the spans between the poles than they are when all the buses are stopped. So there's definitely some kind of pressure or something exists in between here. Okay, now the thing is the further I spread out, let's take one span as our differential element of these wires. Let's say about 150 feet from pole to pole. I take that section of cable and that's all I'm going to look at. Okay, there's a quantity of this magnetism in between these cables, okay, by this circulatory ether condition, pushing the cables apart. Now if I let the cables move apart, or I spread them apart more by putting in another insulator, moving all the cables over, now this will hold more magnetism, obviously. Now if I put a chunk of iron or some kind of magnetic material in between those wires, okay, that magnetic material is going to suck in the magnetism, and again there will be more magnetic storage capability inside this electromagnetic structure. But with the iron, if I keep increasing the current situation of the magnetism so that the iron can't hold anymore, the iron goes into what's called saturation, and it will no longer hold any more magnetism, and all the rest of the magnetism that's produced by the generating station will have to continue to exist outside the iron. It's what's called a saturation condition. All these things are completely archetypal of space. You can only jam so much in the bottle. Okay, you can only fit so many cars in the parking lot. These are all normal properties of space. Okay, now we'll look at these wires a little further. Okay, well, not only are we dealing with the current of 2,500 amps, but we're dealing with a voltage of 600 volts. Because we got to have the volts and the amps, we got to have the magnetic and the dielectric before we have electricity. Okay, now these lines of force, if I take one wire and focus in on it real close, okay, the magnetism goes around like this in perfect circles if the wire's a perfect circle. The dielectric is completely contrary. It's conjugate. Everywhere in space, a magnetic sectional line of force has direction. The dielectric field will always be at 90 degrees of that, and there's no alternation of it possible. Okay. So we have where the magnetism is concentric, the dielectric is radial. And this, if one is one way, the other is the other way situation. This conjugate situation always exists everywhere in space. So if you know where the magnetic field is, you know where the dielectric field is. Okay, now the dielectric field, where magnetism has to form closed loops of a circulatory type of fashion, the dielectric field is radial lines that contact the metal surfaces. So they come out and they arch And everywhere in space, they're at right angles to whatever magnetism exists. So now we have another field of force that exists as a conjugate to the magnetic field of force. And the two of them make up the electric field. Okay, now these forces, the more I raise the voltage, the more it wants to pull the wires together. Not push them apart, but pull them together. So the force is opposite. Now, if I move the wires closer together, these electrostatic lines of force or dielectric lines of force become even more concentrated. So now that I've moved this section of transmission line, the wires close together, the closer the wires are together, the more electrostatic energy the system will store. And it tends to pull itself together, where in the magnetic, the more magnetism there is, the more it wants to push the wires apart and make itself bigger to store the energy. So now we're starting to get into the concept of counter space. We've entered the counter space logic right now. We have two spatial conditions. Okay, now if I take and put a piece of glass in between these wires, like I did the iron bar for the magnetism, the glass will absorb up more dielectric lines of force, and the energy storage will be greater. Now, if I keep turning up the voltage to the point where the glass starts to saturate and can't handle anymore, what happens is, instead of pushing the lines of force out, what the glass will do is start to draw even more lines of force in until the point in which it blasts. That's when you get sparks across power lines, lightning discharges, that type of situation. That's what's going on. Now let's take a lightning discharge as another flux example. Okay, we got the clouds, we got the Earth. Okay, now because we know about these lines of force, we know that there's this volume of space, of ground and thundercloud, that is filled with a quantity of electrostatic lines of force, okay, which are basically trying to pull the cloud and the Earth together. Okay, now what happens is the cloud evaporates, the water, which is holding 50 times at least the amount of lines of force that air can hold, is releasing this electricity and it has nowhere to go. So what happens is these lines of force start to become tighter and tighter. And what it'll do is it'll start a saturation in some spot of air, just like in this piece of glass. When I kept turning the voltage up, it'll start to spark inside and then it'll blast. And so the atoms start to break apart at the point of saturation, and you get a breakdown zone. And what happens is when that saturates in a counterspatial, yes, there's something you want?
Step maybe a bit away from that board for the camera.
Oh, okay.
Thank you.
Yeah. Once the saturation process starts, all the lines of force will come running into that and discharge the complete 1 cubic volume of electrostatic lines of force in one fire column. Saturation is complete and total. There's nothing jumping from the cloud to ground or any of these types of, those are all myths. If you build your lightning protection system on that, you're more than sure to get blasted.
What did you say it was doing?
It's a saturation. It's moving in sideways. It's like if I have a bottle full of water, and the water represents the electrostatic field, okay, and then all of a sudden the water or something starts to break down, like in the middle, and the more water rushes in to make what was gone. It's like the whole jar of water collapses upon itself into nothing. And the energy density is so high at that point that the fire appears. And that's why there's the blast. So lightning is not moving vertically, it's a saturation collapse coming in horizontally, and it produces this what's called impulse current.
It's all the static meant into one line.
Yeah, it's a saturation into counter space. Okay, now when I'm sending the electricity down this line, what's going on, okay, is everywhere one of these lines of electrostatic force and one of these lines of magnetic force cross, there's a co-joining. You have a process of multiplication. It's basically the symbol of multiplication, the cross, which takes us back to that polarity thing. Again, it's always the four-pointed cross. It's an Indian archetype, actually. At that conjunction point, in space and counter space is produced the electromagnetism which moves down the line, and this is what's represented by Planck's constant. This is the product of the electrostatic and the magnetic lines of force, and this is what exists in quantum steps. And this is what propagates at the velocity of light. What rate the magnetic lines of force and the dielectric lines of force move has never been determined. Okay, the equations exist in Steinmetz's book to make the determination, but nobody ever followed through to do the experiments. But they necessarily have to be doing something because the energy is moving. So the movement of the lines of force and the energy, what they do is they're scraping into the wire because the wire is not a perfect conductor, so to speak. But the wire is not conducting this. The space is conducting this. The wire is a reflector. That is basically why all electromagnetic boundaries use a material which reflects light for the so-called conductors, and it always uses a material that absorbs light for the so-called insulators. All electromagnetic boundaries must be capable of reflection, or they will not work. That's the basic engineering principle. I'm sure there's some modern plastics that'll do something, but this is the basic process that's going on. So we have electricity trapped between two mirrors. But the electricity is of such a dimensional nature that it doesn't have to be complete. It doesn't have to be big mirrors. It's just the presence of the cables is enough that nothing can get through them. Okay? Now, the thing is the electrostatic lines of force tend to embed themselves in because they have to make contact with what are called electrons and protons, which are the ends of the electrostatic lines of force. In themselves, the electrons and protons have no material physical existence. They're terminals of this type of electrostatic condition, and this is where the theory of relativity collapses, is in this particular aspect of what's going on with the electricity. So being that all this is in a speed of light commotion, traveling down the lines, it's dragging through the wire. And then the wire basically burns up the electricity, and there's a sympathetic current flow in the wire that cannot move anywhere near the velocity of light down the line. And it's a situation quite analogous where if you're going down the road in your car and you got to slam on the brakes, what happens is as you skid down the road, it makes a sound, okay, which is called enharmonic. It's a distortion type of sound where energy is being destroyed or consumed. And part of the road will be carried along with the car, but not at the same rate as the car. The pieces you rip up will always fall behind, and the skid marks will always be left behind, but there will always be the tendency to move. And this is why the wires get hot and give the indication of current flow, but the current flow is the rate at which the electricity is destroyed. So now what we can do is we can give these quantities symbols so that we can work with them. So we have now, we've talked about the magnetic field. Okay, we've seen what it does. We can feel it. We know why it makes things get hot. We know what it does when we try to confine it or put it in a container. We've got that down. Same thing with the electrostatic. So we'll call the magnetism L, and we'll call the dielectric C. Now the way we derive these is if I take a quantity of magnetism, which we worked with in an analogy, okay, and I take associated current flow that goes with it, that it drags along in the wires, it gives me this quantity L, which is called the magnetic energy storage coefficient. This is one of the most important quantities in electrical engineering. There's 4 of these. This is what I'm going to try to develop. L is the ability of this geometry to store magnetism. If I pack that space with iron, L is going to go up because I'll have more magnetism per the amount of current that I can detect by its movement against the wires. So basically the geometry of the wires determines this energy storage coefficient. Now with capacitance it's the exact same situation. Is you have the dielectric flux, okay, and you have the electromotive force or the magnetism that's associated with it that gives rise to it, okay, and that gives us C, the capacitance of the system. So we have electricity is represented by the quantity LC. So now we recognize that from the Heaviside equation. This is back to that LC, whatever. I'll try to get back into that. So, but now we also have the magnetic field is dragging into the wires and causing them to get hot. So what we have now is we have an energy dissipation coefficient. Okay, and we'll call that R for resistance. And then the electrostatic lines of force have to terminate in the molecules, and that's agitating the situation and getting hot. So what we're going to call that is G, the conductance. So we have LC and RG. So basically, the heating of the dielectric field occurs mostly in the insulation and the insulators of the wire, and the heating from the magnetic field mostly occurs in the metal pins and the copper and all that of the electrical transmission system. The metal pins will get hot even though they are not in the so-called electronic-minded current-carrying path. Is if there's any cycling or carrying on with the electricity, switching it on and off, the iron will get hot as well as the copper. So for alternating current, everything gets hot.
Were you suggesting a moment ago that electrons and protons have no rest mass?
Exactly.
Really? Okay.
They don't have mass at all.
Interesting point. All right.
I'll try to get into that, but then I got to bring up J.J. Thomson. And then we get in, not only do we have two fantastic stories to believe, but then we'll have three.
That's a pretty interesting claim. I'm happy to hear your elaboration on that.
So basically what I've done is now, when you look up at the power lines, okay, it's not just some metal there. Now everybody here can kind of get an idea that there's a dynamic, just like the thing with the car. When you speed up, there's a dynamic that occurs. Things move, things change, things readjust. And this is our basis for electrical engineering. And it's not complicated. It's actually very simple type of thing, as long as we have all these ideas, in our mind that were developed by Faraday and the people that discovered electricity. Okay, now what the Einsteiners tried to do was basically say that there is no electric field. It doesn't exist. All you have is the crossing point, which they call photon. And none of this other stuff even exists. It's just simply not there. Now, you just brought up the topic, so I'm going to get into that. Okay, the thing is the theory of relativity emerged from the writings of a guy by the name of J.J. Thomson and a few others. J.J. Thomson's the most important. J.J. Thomson revitalized the Faraday theory when the rest of the world was going back into the Newtonian action at a distance. To him, the lines of force were real, they were solid, they were there. I did an experiment when I was a kid. It's very simple, determined the same thing. I got a nice set of very sensitive, sound-powered Navy headphones from the Air Force Base. I had a magnetron magnet from one of their radars, and I had a 440-volt relay coil. Lots of turns of wire. Put on the headphones, connected to the coil, and waved it around the magnet, and I could hear the individual lines of force scratching through the windings. There was a fibrous something there. The faster I moved the wire through the air, the higher pitch the scraping noise was. So there was something scraping or acting, and to me that is another experiment to establish the physical reality of the lines of force. Okay, now the Einstein and the physics and all that, see, we're kind of back in the same situation now we were with Oliver Heaviside. The physicists said it was a diffusion problem and based all their work on that, where Heaviside said it was an electromagnetic, a double energy type of situation that had to be balanced. So again and again, these things repeated. So J.J. Thomson discovered a phenomenon called the electron. He is the one that gave us the concept of the electron. And here's how the concept of electron worked in J.J. Thomson's mind. Is in one of these electrostatic saturation conditions, let me take the inside of a radio tube or some type of deal where I've got two metal plates in a vacuum with 100,000 volts between them, so I have this nice intense dielectric field. Okay, it's straining everything. The plates are being pulled together. Okay, what it starts to do is if I keep cranking up the voltage, it starts to pull what it's connected to in the atom out. The atom can't hold it anymore. It's starting to yank out. So what happens is one will break. one line of force will break loose, and you will have what's called an electron at that end of line of force, because a line of force can't just break and end in space, according to the Faraday theory. So this end of line of force, now you have a rubber band of dielectricity that's snapping, okay? And its energy is being discharged in this snapping to the other plate, the positive plate, and that produces a physical action and a heat. Of course, now the Einsteiners said there are no lines of force, so all we have is the electron, which is a ball bearing that floats in empty space. And if we drop it to the floor, then we'll have electrons rolling all over the floor. But somehow that just doesn't work out like that. It doesn't seem to have any real mass. The mass is all related to the rate at which the electric field is moving. It has nothing to do with the physical object. Now, what was found was, just a second, what was found is that this electron phenomenon, if you try to make it happen faster, you cannot, if you have all the energy in the world, you can make it happen at the velocity of light. And anything less than that, it cannot reach that speed. And this is the basis for the proof of theory of relativity. The electron is not a ball bearing. Nobody knows. The only person that knew what an electron was Philo Farnsworth, and he wrote no books, and he's dead. Yes?
Well, the thing is, you mentioned about the cathode and all that. Now, if you have no voltage across it, the anode and the cathode, and you have the heater, you know, because the cathode is a thermionic thing with...
No, this is a cold cathode.
Well, the cold cathode is a different thing. There's two phenomena
Field
that makes the
emission.
cold cathode work. One is it depends on ions. Ions hit the surface of the cathode, and then electrons come off. And that's what they like.
Well,
sputtering.
that's after the breakdown. But you got to turn
Yeah.
up the voltage to the point
Yeah,
where
well,
the
that's
charged
before-
carriers get pulled out of the metal.
Yeah, well, they call that brute force field emission,
Yeah.
which is where...
Now, thermionic emission is where you heat this plate up to red heat,
Yeah.
so the electrons can't hold on very good anymore.
Yeah,
And you can just heat it up to the point where the electrons just kind of boil around the whole thing, but they
Yeah.
got nowhere to go because their lines of force are all going inside. They're not
yeah.
outside.
But
There's
it
no
also results in the
polarization.
cooling of the cathode. Cathode is actually...
Yeah,
cool
it's
current
actually,
through it. The
on a
cathode
field
would
emission,
actually-
Tesla showed that when the anode gets hot, the cathode refrigerates,
Yeah,
which is kind of a remarkable thing in itself. So what led out of J.J. Thomson's idea was, when you read his book, which is very simple, his mathematics is kind of shoddy, but there isn't a lot of it, is that here's the implication of J.J. Thomson's work, okay, is space is filled with electricity. We don't know what the voltage of the planet is with respect to the sun. You know, we can't just say right off the top of our heads of what the magnetic field intensity is in this. But at any rate, if I got my car sitting out in the street, it's being that it's metal, it's got all this electrical lines of force attached to it and surrounding it. Okay, now according to J.J. Thomson, that is the reason why when I slam on the brakes, the car doesn't come to an instantaneous stop. It's because the electricity has to discharge. So J.J. Thomson's idea was, if you took and found a way to make the voltage and the current associated with the metallic body of the car equal potential of where you stood in that place in the universe, so all the lines of force detached, because there's no difference of polarity, that you could step on the brakes and the car would come to an instantaneous halt. And basically, velocities and all of those things would almost lose their meaning because there would be no restriction to the movement. Now the problem is, okay, well that sounds good. How do we begin? Well, the Einsteiners tell us there is no universal ground or neutral wire or point of rest or any of that type of stuff. So we'll have to give up at that point. But at any rate, somebody pointed a gun at our head and said, no, you're not going to give up. You're going to figure it out. So what we'll do is, well, gee, Tesla came up with this unipolar idea where he could ground in the counter space. Well, what would lead out of that is the Tesla device could be phased or tuned in such a way that its counterspatial neutral would be at a universal grounding point. And grounded against that, then your vehicle would have no potential because it would be grounded to this dimension, and all the electrical lines of force would disappear. Now, as a lot of people believe that the Germans developed that in aircraft, and the United States glommed onto all of them during World War II, and they did indeed disappear into Bell Telephone and some weird place in New Mexico I can't pronounce the name of. Who knows the name of that? Algamorado or? Okay, yeah. So the contention is that all this talk of aliens and UFOs and all that is just a weird type of compounding disinformation story where they actually throw the material out and then deny that it exists, so the whole thing just becomes a self-consuming lie, and nobody realizes it's really actually Earthlings doing this stuff. But of course, that's all, Art Bell world, so I won't get too hard into it. But these are all the things that pop up when you get into this electrical world. And it's my conclusion that that's the main reason why all electrical research has been stopped and swept up, is because the possibilities are incredible. Absolutely incredible. So, some more questions.
Well, speaking of Art Bell, because he had his parallel line loop antenna, do you think because of that particular configuration, and he had this other space between those two lines, that's why he's sucking all that voltage off?
No, the reason he's getting all the voltage is because it's a great story. Art Bell is an entertainer. You've seen the same piece of loop of wire, you've virtually touched it at my place, and that's just not happening.
But they did have this very long, exactly parallel matched loop. I thought maybe that configuration matched your model for the dielectric field in between.
No, Art Bell is an entertainer like Michael Savage.
And my last question would be, just to make sure I got this, because I'm still trying to figure this out. You're suggesting that protons, electrons have no rest mass, but that their apparent mass is a function of the velocity of the force lines. Is that correct?
Right.
Okay, it's a theory. I'm digesting it, but it's interesting.
Yeah.
Before you ask the question, could you elaborate on your last statement about the information about electricity being gathered up or whatever?
Well, if you look at electrical history, okay, you can see it was just a ball of confusion for 300 or 400 years in Europe where, such things were observed. Obviously, the Hawaiians and the Aborigines weren't doing much experimentation. It all came out of that neighborhood. And then it just, boom, it took off. Twice it became, with Franklin, it became almost like a fad that everybody in France was wearing lightning rods on their hat. I mean, it's just every phase of electrical advancement resulted in this social reaction of complete amazement and partying, like when the telegraph line was finally sent across the ocean and all that. It was massive effects. There were riots on the street when Einstein and Darwin presented their theories to the public. See, all these things have disappeared from the history books. So you go through and you see, if you read, what I did is I read all the minutes of the American Institute of Electrical Engineers from its inception to the death of Steinmetz. Page at a time. I went through everything, looking for, clom, so to speak. Little goodies, things that I could, get something out of. There was one meeting where all these guys were together. And they felt that within a matter of months, with Steinmetz's work and Tesla's work and all the stuff that was being discovered by Heaviside and all these other people, it was a matter of months before a rotating apparatus was going to be built that provided electricity without requiring a prime mover. It's right there in writing by the chairman of the meeting, Professor William Anthony.
And what happened? Why?
It just basically step by step, because of the physicists and the Einstein and all that, just got chopped and chopped and chopped until eventually electricity has been declared impossible to even exist. Every device that hangs on those telephone poles now, every electrical device you have cranking or whatever's going on in your car, any electrical device that's pulling the elevators up and down, running the blowers, powering these light bulbs, or any of that stuff at all, was all invented by Edison and Tesla and a few other guys.
Who was
And,
doing the chopping?
well, I don't know, figure it out.
Well,
All I can do is speak from experience, okay? Everything I've built has been destroyed.
right.
Let me finish. Okay, I'm just going to speak from my experience, okay? Everything I built has been destroyed, okay, is people have been hounding me and harassing me my whole life, ever since I was 6 years old, even before I came up with anything. It took a while to figure out why all this worked, okay? And I won't get into it, but I'll get into the specific example, okay? The thing is when I was a child, okay, I wasn't interested in riding bicycles or kites. I didn't need to go goo goo gaga, see Dick run, see Jane run in the classroom because I was too busy reading my father's naval and electronic engineering books. That's how I learned to read. I just sat down to open the books and read them. I don't know where I learned how or whatever, but that's immaterial. That's just what I did. I probably got enough out of the kindergarten class or something. Okay, when I was 12 years old, Pacific Gas and Electric took me on in a private tutoring special education situation. Okay, and then the phone company came next. Once I had all my federal licenses when I was in high school, the phone company came in with a couple of spooks that looked like some CIA guys with, you know, the gun in their pants, but not quite, you know. Where's Eric Dollard? You know, and it was a couple of stunts that me and my buddies pulled the week before. I was not feeling happy. And they go, we want you to attend this meeting, special meeting. And it just kept going and going like that. And then RCA came in Bolinas. Okay, and when I was 17 years old, I was completely absorbed into the station. I could come in there any time of day or night, get parts I needed for experiments, had the keys to the gate, you know, so we could party on the beach, all these type of things, okay? RCA, the phone company, 1970, what me and my friends called the day the music died, okay? All those companies started going down like that. So what I did is I managed to glom on to a couple of corporate engineering executives in these companies, okay, and told them what I had set out to do, electrically researching, and I had the full backing of these big corporations. RCA gave me all of their equipment in Bolinas, except what was actually online. 25 tons of apparatus.
To do what?
For my research. Transformers that stood 7, 8 feet high. There's a few people here that were with me in that episode. Actually, only one person. I don't know where she is right now. But that's it. Nobody, that's all gone. There's no see or belief or anything. An environmental organization came in, seized the whole situation, hired high school vandals to smash all the equipment with hammers and axes, spread the mercury and the PCBs all over the floor, the environmental saviors, smashed everything, cut all the cables, dumpstered all the notebooks, tried to make sure I had no place to live in town.
Yeah, but they were hired by.
No, they own the place now. They just simply took it over and then pushed RCA, what was left of it, to the other side of the wall,
Yeah, but
as
then
we
they
said.
were hired by other people who were hired by other people.
Well, I don't, that's all for other, that's for you to figure out. I'm just leading the trail. You go talk to these people, okay? You go to Bolinas and you go to the RCA station and they call themselves Commonweal. You talk to them and get their story. That's how you deal with those type of people.
Well,
Okay, they managed to
they
get
were
the-
hired by other people.
So at any rate, let me continue. I don't know who, you know, I'm a scientist and an engineer. Okay, I can't speculate, otherwise I'd just burn my whole life up chasing UFOs and space people and Soviet Tesla scalar conspiracies. You know what I mean. So what it finally evolved to is a guy and a friend of mine got together with me and we went with a videotape camera, okay, and went out into RCA to get pictures of the last of the antenna field and everything before it was finally smashed down. Well, in the process of this, by some weird turn of events that I won't get into because it sounds like voodoo, it finally resulted into the chief park ranger himself, Mr. Sansing, searches the entire 3,000-acre antenna field, which has been my personal rat hole for 30 years, to find the hated Mr. Dollard. And he finally does. He finds us down in the ravine, taking a break, you know, where the deer hang out. Not easy to find. He must have took him at least an hour, you know, worrying about tire pungees and low-hanging wires and the whole thing. And they found me, and he did that so he could come up to me and say, quote, Mr. Dollard, there will be no more electrical research done here ever again. Do you understand, Mr. Dollard? You know what I told him? No. And it didn't stop there. So you figure it out. All I know is it's just, you know, is that percentage of carbon monoxide in the air that I got to live with.
But what about all the hidden budgets now in the executive branch of the federal government?
I don't know anything about that.
Oh my God, they can take all your research and turn it towards military use.
Well, good. Let them blow up the world.
Well,
They're going to do it anyway. Have you heard about the National Ignition Center? Oh, it was on KNX News in Los Angeles. We had a whole party about it in Bolinas, amongst a couple other issues. What they're going to try to do is set off a nuclear bomb and contain it in the East Bay in one of their laboratories.
where?
I don't know if anybody can confirm that, but if I hear it on KNX, I believe it.
The straight, that's been, they said they're not gonna do this big straight, hit because of put radioactive dust in the air.
Well, whatever. They're crazy.
They're still doing a contained version of it. I mean, that's been.
So here's the basic situation. You got this place. I don't want to insult anybody that's worked there. You have this big installation, Livermore Laboratories, the big government laboratory.
Right.
Big shot government laboratory. And out of the whole fusion era came this holy grail of producing electricity by hydrogen fusion, which didn't throw out all this garbage and crap like fission does. It's more of an implosive, self-contained type of thing. All the billions and billions and billions of dollars, giant magnets and lasers, 220,000 volt power lines on towers, 150 feet high, insulators 20 feet long, big giant flows of money, gas, electricity, and glom pouring into this place, all for one simple engineering premise. They wanted to make a fireball stand in space. Okay? Well, nobody seems to be able to do it. Well, when I was living in the bushes in Bolinas, there was a deranged guy that lived in a house next to the bush. Okay? His name was Philo Taylor Farnsworth III. So I began to get drunk and stoned with this deranged man, okay, and was told that he's really off his rocker, okay, and nobody wanted to even bring me near him, and I didn't know, and I looked at his facial features, and I go, well, he's got to be a Farnsworth. So at any rate, we get drunk together, and the first thing, the drunken mentality, along with all, the foul language and puffing up like frigate birds, my transmitter put out more power than yours. And the whole thing, it results in that I tell him one of my best stories, which happened to do something that created the beginnings of a fusion reaction. What we used to do when I was a kid is the science club was kind of also the pyromania club in those days. Janet Reno wasn't invented yet, okay? So weird things would happen. So in the course of experimenting is I could get all the old tubes from RCA. I had moved a 10 kilowatt transmitter from RCA into my parents' garage. Okay, this thing was the terror of the neighborhood. Well, I found out this terror spread a little farther than that. So what we did is we get these big tubes, back then these giant globes, and of course the ones that were good, were very carefully taken care of. But the ones that were no good, if you still could get current through them, okay, as my parents once a week would go out to a movie or something like that. So the whole science club would show up to my laboratory, okay, and we would play Nuclear Meltdown. And this is what playing Nuclear Meltdown was. We'd take the tube, okay, we'd hook it to the big 3,300 volt switchboard. This thing's got about enough juice to run a whole neighborhood. It's clamped right where the wires come in off the meter, on our side of the meter, but nevertheless had to be clamped right on. It just draws so much power, the whole neighborhood would just go into a brownout every time the telegraph key was hit. So it was a 3 or 4 person operation. One man controlled the plate, one man controlled the screen, one man controlled the control grid, and somebody kind of had to deal with the whole, to get this thing hotter and hotter and hotter and hotter. Okay, and the thing all of a sudden would go at some point and would take off, and all the meters, the big Frankenstein switchboard, all the meters would go backwards, okay? And the bravest guy had to have his hands on the abort switch to interrupt this sudden explosion of electricity that would be created in this process. Just briefly, there'd be this sudden explosion of electricity. Well, it turns out to be fusion reactions of this type are very heavy microwave emitters. And I learned when I got in the Navy, every time we did this, it jammed out all the radars in Hamilton Air Force Base. So when I told that to Philo, oh, he was just completely bent out of shape. He couldn't have a better story than that, but he had to. So he disappeared into his bedroom. It was a typical madman, house of boxes, books all dusty, piled to the floor, the ceiling. You couldn't turn the TV off because of the weak cathode, so you put a piece of cardboard in front of it. The inventor of TV's son couldn't fix his own TV. It was a madhouse place, Lots of bottles of wine going down in his guts all the time. Drugs I've never even heard of before. But at any rate, that's where the action. When you live on the street, you're more tolerant. So he goes into his room and he pulls out this screwed up cardboard box, about this big, and he dumps it on the table, and he goes, well, you're so smart. Tell me what these are. And I go, what do you got here? He goes, these are my father's tubes. Okay, well, I knew about the TV, but these weren't TV tubes. Okay, so I pick up the tubes. I've been playing with tubes since I was 6 years old. My grandmother used to build them in RCA. It's just in my genes. I look at these tubes, and these things they're crazy. Anybody would say this is insanity. Okay, big giant grids, but no cathodes, and like electrodes sticking out of the side, sticking all this stuff, and but the thing is, I know how to make tubes. So I'm looking at him, and I start to see what's going on here. He's sitting there. Remember that cartoon character of that dog that would laugh with that kind of horse after the dog screwed somebody that screwed him? I forget the character. That's exactly how Philo laughed. It was that kind of... You couldn't really hear it. It was kind of like a growling inside. He was content. So I pulled this one tube out, which was just an empty quart of glass, and it had an umbilical cord, so to speak, that came off of it to pump all the air out during operation. It was a laboratory tube. They broke it off the pump and discarded it after the experiment. It had two little metal shells pointing at each other, kind of like two little mirrors, coated with some kind of crappy-looking stuff, silver cesium oxide compound, and a simple ring in the middle. Well, it's a simple, electrostatic focus tube with an anode in the middle, and the two plates, and little tiny wires came in because the voltage was so high. I guess it had to be oil or something around. It looked like it operated about 100,000 volts, which is a lot for a small tube. But I look at the glass had been all attacked by something. So it used to be in the old color TVs, there was a certain tube that shorted out the high voltage so that it couldn't get out of control. It's called a shunt regulator, 6BK4. And they go every color in the rainbow and make the TV repairmen sick. And what it does is it turns the glass, the radiation turns the glass on the tube chocolate brown. And that's how you can tell how long the tube's been in the set. So I'm looking at this glass, and it's like all baked by some kind of incredible electrical activity that couldn't have come through those little tiny wires. So I go, Philo, something took off in this tube, didn't it? And then he stopped laughing and got all crappy with me again. I go, Philo, tell me what happened in the tube. And so he told me I could see what happened. What happened is and this is about 1932, is Farnsworth was working with a radically new vacuum tube technology, did not use any of these glowing cathodes or any of these emitters. The patent situation back then was such that RCA owned radio, and you couldn't build anything. That's what started in Bolinas with the Alexanderson system. Lit this thing up, a star appeared in the middle, turn off the power, and it stayed there for a brief period of time. So that changed my life forever. So here you have this giant laboratory and all these billions and billions and billions of kilowatt-hour dollars being expended and all the grooviness and frigate bird activity that goes along with it. And here's some guy in a laboratory on Green Street in San Francisco, okay, on a poverty existence because he's never got anything out of television, does the same thing in an empty bottle, for so to speak.
Where are the tubes now?
The Farnsworth family still has them, but it doesn't stop there. So what happened is my first laboratory got destroyed in San Francisco, and that's when I lost most of the RCA equipment. That's all based on the campaign slogan, Diane will make a difference. So that's when San Francisco basically swirled into the outgoing tide. So my 8 cents a square foot went to $1 a square foot. So now how are you going to move tons of switchboards 15 feet high, transformers that weigh 4,000 or 5,000 pounds? Commonweal had already smashed the rest of it at RCA. The Park Service got my warehouse at Fort Mason Pier 3. So everything went to the dump. And it was time to eat out of garbage cans again for another couple of years. So what I did is I made friends with a high school kid up there in Bolinas who was a prodigal genius type thing that Philo had trained at an early age. The kid was a genius beyond belief in a lot of different areas. He started hanging out with me. So we built a laboratory in his bedroom. So what I did is I took some of the remaining pieces from RCA and configured them. I decided, well, there's nothing else to do with this stuff other than make a Tesla coil. But make it the way Tesla decided to make it. At any rate, to make a long story short, we worked with this, we experimented, went out to RCA, got more transmitter parts, because, you know, I could always go back out and get more, because the company was still, station was still operating then. We build this thing, I take old burned out street lights, we're using the experiment, we get dumpster loads of them from Lease Light in San Francisco. The street lights off of Van Ness Street. They pull them out every certain amount of months, and there's a whole dumpster full of them somewhere. There used to be. Put the street light in these monopolar fields that I just described from these coils, and the street light that we used for this experiment was the one we'd used previously for all of our spark gap experiments and everything, and something had started to transform with the bulb. We put this thing in the field within a matter of a minute or two of working the thing in the field. You have to be careful because they explode violently. Full galaxy appears inside the bulb, just like a picture of one of these Nova TV deals. You can spins, whole thing, the stars, the nebulas, the suns, all the colors of the rainbow is spinning inside a burned out street light and virtually powering and containing itself, which has gone beyond the Farnsworth. Now we have a whole astronomical creation floating around in a light bulb on a workbench, and then it explodes the bulb, but after it explodes the bulb, for like 1/10 of a second, it's not long, it sits there without any bulb to contain it.
What is it? What's in it?
That's the creative force. This electrical monopolar field is how creation comes about. There is no evolution or any of that type of stuff. It's the electrical field at the time creates what exists, and it's always changing this way and that way. All living organisms are all based, just like all machines, are all based on the same mathematical function. All trees, plants, flowers, humans, everything's based on what's called the golden ratio. It's a definite geometric pattern, and all of these electrical discharges associated with these Tesla transformers are all golden ratio proportioned and tend to be self-organizing and self-powering. So that ends the story. $1 trillion in the Livermore laboratories, and a deranged high school kid and a homeless person go beyond it in the laboratory. And that's how I was endeared to the Farnsworth family. Because Philo's mother, which was the wife of the inventor, came to the laboratory to see this, and when she saw, you know, that this is going on with junk and no money, and her husband had devoted half of his life to researching this, then it was time to start being friends and talking. So I had their whole Farnsworth notebooks and everything available to me, all of it.
He's referring to Pem Farnsworth, who spoke to us in 2002 at the Tesla Society by phone on the anniversary of the 75th anniversary of television, invention of television here in San Francisco. That's the same person, Pem Farnsworth.
Yeah, your question.
The neutron, does it have mass?
I don't even know if it exists.
Very well, thank you.
It doesn't enter into the electrical equation.
The star, you can reproduce the effect that you described, the astronomical emergence. This is reproducible for you?
It's hard, but yeah, it can be done.
It's not like you did it in a field with some broken stuff.
Well, what I did is I built a radio transmission device based on Tesla's work, and I built a pair of them so it couldn't transmit. It could only focus in one spot. And there's a neutral plane. If you take two monopolar fields and point them at each other, there's this weird neutral plane between them, and it's kind of like an opening into another universe.
What was the frequency of this transmitter?
This one operated, the frequency's immaterial pretty much, but it's got to be an HF band. It operated at 3.3 megacycles.
All right.
The voltage was about 60,000 volts. The electrode area at each end was about maybe 15, 20 picofarads of capacitance. So basically the tube sat between the plates of a capacitor, so to speak.
Eric, I have pictures of Bolinas we can put up on the screen if you want to talk about that at all.
Okay, well, what's the time frame and which way does everybody want to go? Because I can keep going in any direction.
Further, how about an intermission of a few minutes?
Yeah, that might be good.
Okay.
Yeah.
Thank
And
you.
one more question?
Yeah, I just wanted to make an announcement here. Hal Tracy, who is a member of this group who lives in Nevada and couldn't get here, made a copy and sent me a table of contents for a book he wrote called Wireless Radio, A History of the RCA Bolinas Facility. I have copies of just the table of contents, and I guess we'll just put it up there if anybody wants to see that. And I think he's also trying to put together some other...
Well, I'm putting the whole thing on the internet right now.
You are, okay.
Yeah.
We're gonna put a whole bunch of this.
That's my last book. That's what's sitting up here. What I started was, try to get some simple facts down on the station, and it emerged into like a 3 or 4 year intensive study, which basically resulted in me learning that the Alexanderson system was not what they taught me at RCA or in the books. It was way beyond that. So that became my most recent and present form of research, is the RCA Alexanderson system that was in Bolinas. That's when you were out there?
Yes.
Okay, yeah, well, that's the wreckage of the station, but it's better than nothing.
This is Bolinas.
Did RCA know what they had?
RCA, here's how the whole situation came about. Okay, Marconi robbed Tesla and came up with a completely impedance mismatch system compared to Tesla, but it got around the patents and it kind of worked. It really jammed a lot of juice into it. So he built 5 stations around the world. The pilot station was in New Brunswick, New Jersey, and the first operative steps out of that was Bolinas and then Hawaii, and an attempt to get to Japan. What happened was, being that Marconi was a foreigner, and this war thing was building up, this was around 1913, 1914, the Navy decided that Marconi was going to get the boot. Okay, at that time, General Electric had, through Alexanderson, had finished developing the Alexanderson system. So the Navy had Alexanderson come to Bolinas and reconfigure the whole station to his system with the full embodiment of the patent. In other words, the antenna with the scalar function, not a velocity. The whole thing was built there because the space was so small. New Brunswick and Radio Central in New York had all the space in the world, but Bolinas was so small, and it was RC. What the Navy did is, once Bolinas, the plans were drawn up and things were ready to go, and the Navy formed the Radio Corporation of America to take over Bolinas and New Brunswick and be the rulers of radio. The Navy, particularly this Assistant Secretary of the Navy, Franklin Delano Roosevelt, decided we must even go farther with this and outlaw radio completely. And it was illegal to own a radio in 1919. Basically, 1919 is a signal year for the death of electrical engineering. RCA was formed. They formed a patent pool and a trust. Nobody could build tubes. Nobody could build transmitters. Nobody could do anything unless RCA decided it was to their behalf.
Is that the antenna right there, Bolinas?
That is the last antenna array to go up, which has nothing to do with the Alexanderson. All the Alexanderson and the Marconi stuff is in this book here.
You wanna explain what we were looking at?
This is all garbage.
Okay.
It's dead garbage.
Okay.
It's, I don't know how, there's a lot of material. I could just go from page to page in this book. So why don't we just take a break now, and then we'll see. Well, how much? Thank you. Yes.
There was just a short gap between Tesla doing his standing lightning and him being on the streets, and I missed what happened, if you said anything about what happened in between.
Okay, well, in 1900 is when Tesla completed those experiments. And then by 1903, he had managed to get the money from J.P. Morgan to build a permanent plant in Long Island in New York. And then about halfway through the construction, Tesla was dragging his feet and spending too much time experimenting. And Morgan got the idea that this was going to be a self-powering system and just cut Tesla off at that point. And he was blackballed. He couldn't get any money to do any projects after that.
Threw him out on the street, so to speak.
So to speak. Yeah, I mean, he had enough, rich friends. I mean, he used to wine and dine with the royal elite of New York City. There was nothing that the elite would want more than have Nikola Tesla for their dinner guest and have the opportunity to get a demonstration of his laboratory after dinner. People came from all over the world. Kings, queens, everybody. Everybody came to see Tesla's laboratory and have dinner with him. So 1903 to 1905 would be the period in which Tesla became a nobody.
Wow.
And he died in 1943. So that's kind of a long sentence as a street person.
Would you want
Yes.
to, I'm sorry.
Go ahead.
I was just going to say, would you want to comment on things that were taken from his laboratory when the FBI raided?
Well, see, I don't know anything about that. All I know is stories. See, I only can go on things that I can,
That's fair enough.
otherwise I can just go, yes.
Could you elaborate on Tesla's impulse electricity?
Yeah, what it is the electricity changes at such a rapid rate in time that it gives rise to kind of like a shock wave condition.
Is that frequency dependent? Or
The frequency is imaginary. It's not in cycles. It's in meters or decibels. So I'd have to get into mathematics. So that's one thing. Okay, you had a question.
I had heard that they withdrew their backing for him when he started talking about free power for the public.
Well, that's how the story goes.
Yeah.
But, I wasn't there. But obviously, there was a falling out. But see, the thing is, there's a whole direction. I mean, Tesla was taking this electricity thing and just going too far with it. And the Einsteiners and all that stuff was getting cooking about the same. I think Einstein got his start in 1905 with a paper on the photoelectric effect. And that photoelectric paper basically is what erased all those lines of force. Remember when I was saying how they were erased and all that was left was in the middle? But, that not being my particular area of study, I can't say exactly, how it worked. But Tesla's comments on it were pretty, well known. He just railed against relativity and the fact that you can get energy out of matter and all these type of things. It's never, and then you start looking at the way Tesla's stuff worked, and you start to see, well, if his stuff works, then he must be right on some level, because he was able to engineer it. It wasn't just a story. Nobody can duplicate Tesla's work. It's just, nobody can duplicate it. I mean, it's possible for somebody to duplicate it, but as it stands right now with mind virus that exists in people's heads, they can't duplicate it because they don't know what it is that they're doing. They don't know what they're engineering. They're too busy arguing and fighting and making improvements. And the best you get out of is machines to make giant sparks. My contention is why build a machine when you can go out and throw some wire over the telephone pole and get all the sparks you want? So it's just, that's where it went. Big spark generating enterprise, and nothing else out of it.
Would you want to recreate his experiment where you got the minute-long lightning bolt out of the ground? Would you want to try that?
I think the FCC would complain.
Well, in a different part of the world, maybe.
Well, as long as the Navy agreed to sponsor the project, so they can take the blame.
This might get folks upset. Okay.
Well, your whole .com reality might go into a meltdown. See, the thing is these type of waves can't be stopped by metal. So that causes, that's one of the threat aspects. That's why people would rather that none of this ever happen.
So it sounds to me, I keep going back to this, but it sounds to me like the Philadelphia experiment was a kind of an edge around this.
Well, the Philadelphia experiment was a story. Okay, nobody was at the switchboard that I talked to. I don't have any of the tubes or relays or sockets in my glom pile that I know of. Okay, I got a little piece of just about everything, including the space shuttle. But allegedly, the only thing that came from the Philadelphia experiment was the 89 beam power tubes made by RCA, but that's by Preston Nichols, and he's the disinformer geek. So he's the one that's pandering this whole Philadelphia experiment thing, and Montauk, mind control. They're all paid disinformers.
Yeah, well, the mind control stuff is hocus pocus, but I'm thinking if you're...
Like I say, what I know is okay, is I took the Minesweeper apart. Okay, I read all the books before the Navy pulled them out. A lot of it's about it's classified, so you know the ship was obviously sanitized before it was dumped. And the Navy came back and wanted to share in the glom on their own vessel. And this Minesweeper and the mine evading technology is to make the boats invisible to magnetism. Okay, and how this is done is they have 3 sets of cables. Okay, they got ones that run in the X, Y, Z axis throughout the ship. Okay, and then the current, instead of running crosswise in the cables to neutralize the field, runs the same way. So these cables become giant magnet coils. Okay, these all go to a classified switchboard. Okay, and in this classified switchboard, there's certain sensing apparatus at some part of the ship that feeds these coils with a variable current, okay, and neutralizes, like I was saying, with the car body, so that you would get rid of the lines of force, so you wouldn't have the inertia. It neutralizes the magnetic visibility of the ship. Now, exactly how it does it is a classified operation.
Is it done with AC or DC?
Done with DC. Now, if I was to do this for the Philadelphia experiment and somebody said, do it or die, first thing I would do, instead of making the current go in the same directions, I would make it all go opposite directions like it normally did, but I'd do it in such a way that it generated one of these type of waves I was talking about and see what happened.
But if you,
And that would involve impulses and not direct current.
but if you're working in space, counter space, time, counter time, that suggests that at least you have like the beginning edge of like an entire Pandora's box of how to create like vacuums in this. What it
Well,
feels to be.
see, here's the thing. This is the reality that electricity lives in. Okay. Now, as far as anything else, like having people walk into something and appear in another world, or you know, physical mass or weapons, or see, the thing is, electricity exists in forwards and backwards time, and space and counter space, but that doesn't mean that the chair does, or the aircraft that they want to make invisible. You see what I mean? It's
But
making that step.
But something inside a field would then appear to be outside those parameters.
Well, that's possible. See, that's all the stuff, that's where experimentation and research comes in. You have to experiment. You get the idea, you do experiments, and then you start to get results, you know, and then you learn a couple boo-boos, and maybe there's a big fireball, or, you know, something blows up, and $1,000 of transistors are fried, and then, you know, and then you try this, and then, you know.
Well, I guess my question would be if you...
Shortens your beard a little bit,
Right.
and then you make another attempt.
If you were like allowed to play in the lab, would this be something you might want to look at?
Well, I have my lab right now. You saw it.
Yeah. A larger lab, a much larger
Right.
lab.
Well, it's, you know, I don't really know. You know, if I walked up to you and handed you $1 million and demanded you tell me what you're going to do with it, what would you tell me?
I'd probably say let's talk in private. But I have
So,
ideas.
right now, what you saw down there and everything I described to you, that right now, that's my main. If I get any money, it goes in that direction.
Understood.
Now, the thing is, I would like to get one of these light bulb things back together
I
again.
agree. It's gonna be good.
I would like to get one of those back, because the last one I got built with the money from Reynolds and all that was basically hijacked from me. You know, I got a little small one I was going to put together for George, but somebody's got to be paid to build it. You know, but my workload is pretty full up right now with keeping that place operating. So, I mean, you know, when you have your own Navy base, you know, and you don't have any Navy funding and you don't have any Navy sailors, it's tough. So basically, I have my own Navy Electronics Research Institute, but it's just me. But, like I say, you know, you put the information in your head, you go experiment.
I might.
You should.
Okay.
That's what I'm encouraging. I want everybody to get out and experiment. I want everybody to read the books that I read, and if they want to learn, and do it. I mean, I documented all the references. Don't listen to me. Go to the references, the people I got it from, and learn from them. Otherwise, you know, I got to bark myself silly trying to get this across to people when the experts, you know, did write the books. But it's a lot. We're going to take you about 8 years. But I mean, just the thing to start with is Steinmetz' basic book, impulses, waves, and discharges. And he starts to work the concepts in your head. Get a copy of J.J. Thomson, Electricity and Matter, and just read them. But don't argue with them. See, that's the whole thing. Oh, no, we have this new concept. No, we don't have the new concept. We're talking about their concept. See what I mean? That's why the duplication is not possible.
Do you want to comment on the Integratron at all?
Let me get a few more ideas, and then I'm starting to get an idea of where I'm going to go. Any more, anything people in particular want to know about? Yeah.
Just curious, what I've read about Tesla, there was comments that he thought his turbine was his greatest invention as opposed to his electromagnetics. Do you have any comment, or have you come across any of that in your reading?
Well, he was at that was around 1916 where he found a new way to make money. Came up with a new invention, so it had to be the greatest thing that he came up with. And he managed to get a space in one of Edison's power plants to experiment with it. And his personality pissed everybody off. And it just got back into the same situation again, and it didn't last that long. The turbine is only useful with his devices because the RPM's too fast. So all you can have is high-frequency devices. It's no good for 60 cycles a second, but it's great for 600 or 6,000 going up there. But 60 cycles a second, it's just, the thing's way too fast. That's the problem with most of that Tesla technology. The stuff just goes way too fast. Where it found its practical applications is in clog-free pumps, where the power, instead of going out of the shaft, is going in the shaft. And there's a big business in San Diego called Disk Flow Corporation, and they make their money using the Tesla, what do you call a centrifugal pumps and turbines, and all these. There's classifications of machines. So any type of centrifugal pump or any of those type of things, the turbine, where the Tesla turbine is a centrifugal device. In other words, the liquid can't move exactly the same speed as the mechanics. For a positive displacement device, something more like a bladed turbine or whatever, it tends to get locked a little tighter. Like I can take a centrifugal pump and I can shut off the output valve and nothing will bust. But if I try to do the positive displacement pump, if I shut the output valve off, I got a bust crankshaft or a connecting rod or a hole in a piston or something like that. So it's a kind of impeller technology, but being that it had no blades or discs or slots or any of the stuff you find in a conventional centrifugal machine, is the velocity's got to go way up to get the effects. And then the efficiency goes up accordingly. And then you hook that to Tesla's high-frequency electrical machines. Well, now without a gearbox, you got the speed to get your 50 kilocycles a second. Where Alexanderson had to have this horrible gearbox go in between the electric motor or the turbine to the generator. With the Tesla stuff, is just straight across, so the efficiency would go way up. So Tesla invented the turbine basically for his technology, but the pump came out of it. Because there's nothing for the boogers and the cigarette butts and all the stuff that when you're pumping the sewage out of the bilge, there's nothing for it to catch on. It just gets pulled right through. So that's its practical application, yeah.
Well, Tesla had this transmission turbine that I believe the term transmission turbine would indicate different diameter discs, and the smaller disc would have smaller RPM.
You're talking about a staged turbine.
Yeah.
The staged turbines are usually all on a common shaft.
Right.
So they have to turn at the same speed.
Well, yeah. Well, I was actually thinking on another level about the using the electromagnetic thing. You've got a field thing going on there. Couldn't they incorporate electrics into that turbine?
Well, but then it's not a turbine. Then it's a motor.
Yeah, but it could be used that way.
Well, you're talking about compounding two different technologies into the same machine. So build one and see what happens. Okay, that's...
We have 11 people on the list, Eric, that would like to attend classes if you're willing to teach them with it.
Okay, well, if I can figure out a way to get over the big hill once a week.
Or once every other week,
Yeah.
whatever frequency you like. And I'm wondering, would the people be more interested in experimental work, building stuff, or in the electrical theory?
Everything.
Yeah, it's just everything.
Okay.
Yeah. Whatever people want to do. You know, if you got the money to go buy parts, you can't find this stuff anymore. If I got the last glom, it's gone. Tubes I use in my equipment, there's no money in the world that'll buy them, and nobody can make them. Nobody can make anything that works anymore. It's over. Babylon is here.
Why?
Well, I don't know why. That's just what happened. Maybe the Bible says why. Read it and see. Okay, so, yeah.
Are the Russians still making vacuum tubes?
Yeah, they're the only ones. Well, actually, Sweden's making tubes too, and all around that part of the world. And I've seen the recent tubes that come out, and the quality is just stunning. And they're key to keep the, see, the tubes are real popular in the audio business. So there's always a market, big market for tubes.
So those,
And being that it's a fad, it doesn't matter if they sound any different or what the thing is. Everybody just wants them because that's the fad. You know, it doesn't matter. It's still the same old 1928 RCA circuits or any of that. It's just people want to go back to that. This has really not that much to do with the difference between the tube and transistor. What it is, it's the tube and transistor circuits are different.
so those tubes, the modern tubes are adaptable to what you want?
Well, the thing is I had to, I use the vacuum tubes either kind of, how would you say, as a sculpture. In other words, when I build equipment, I go for a certain archetype of a certain era. So the vacuum tubes are used where you could use a transistor. It wouldn't make any difference, but I want to stick with that era technology. But my earth signal receiving system has to use these special tubes that were designed by a telephone company. They have super amplification capabilities and they don't wear out. And those tubes are priceless. Some of them go for $1,000 a piece in the audio business. The reason for using the tubes is these earth impulses are so intense. They last for very short periods of time, but they're so intense that they tend to burn out the receiving devices if they have semiconductors in it. So, and then my antenna field is in a major lightning zone. So, you know, I have bolts of lightning dancing around me 2 or 3 days out of every summer. And the transistors, you hook transistors to that antenna field, and they're history.
That's what happened to Joe Tate before the 1989 earthquake with his apparatus that we talked about here. And it was all transistors that all blew out.
Yeah, well, I mean, when you were down there, you saw the pulses on the scope. Those things have a very high amplitude. They don't last for long. It makes them hard to see.
I think the term is toast.
Yeah.
Yeah. Well, it blows a hole in it. There's not enough average energy to cook. Blows a hole in the semiconducting material. Just like a bullet. Just cracks it. So it's just like, you know, a lightning discharge doesn't, you know, the pulse tends to want to break things more than melt them. Because it's just so much at so little of the time. That's why it produces that, you know, detonating sound. So the frying would be more like, you know, if there was something continuously going. But from what the old descriptions of the telegraph, obviously these telegraph lines were picking enough stuff up where the aurora borealis appeared in the telegraph office. See, the aurora borealis is not a normal light bulb glow discharge. There's something funny about it. And that's never been addressed. It's not something that you can create by taking, you know, making sparks between two plates.
Is it more like Northern Lights?
Well, that's one about the Northern Lights, but there's something funny about it. There's something that doesn't add up. It's not just a neon bulb glow discharge. There's something about it that's different. The guy that got into this is Jerry Vassilatos. Have you ever heard of him? Jerry Vassilatos did an interesting thing. So I gave some lectures in New York or something about, I forget what it was. He decided to start experimenting and then do the same thing I did. He went to New York Public Library and he went to all the old books, all the way back to Ben Franklin and the original, you know, writings about Galvani, and, you know, where you had to know the old English letters, you know, where the S's and the F's are the same. And he went back to the primitive reality and photocopied all of it and made it in a sequential thing consisting of 12 volumes of about 200 pages each called this a compendium. And the entire history of electrical science is in these photocopied library papers or, you know, the photocopies of the books. And it's incredible what these people were doing back then and the concepts they had. So I went, you know, for months straight studying these things. I started getting all these flashes. And that's why I returned to the Alexanderson system, because I found out from his photocopying and digging that what I learned from RCA about the Alexanderson system was completely false, including the plaque they put on the Marconi building that says that RCA finished it in 1920 when Marconi finished it in 1914. So if people want to know a little more about that Bellina station, I can get into that. Or let's see, there's a couple other, you want to know about the integratron, but that's getting into, that's just a little farther. Yeah.
I'm curious about the history of the concept of just the term scalar, and then how it is alive in your own particular thinking, if it is.
Scalar, by definition, the scalar is that, let's go back to the Heaviside telegraph equation. So I'll give all the terms. The Soviet scalar technology hoax is mainly the work of an Army colonel, I believe, by the name of Tom Bearden. And it's exactly what it was. It was a hoax. It was designed basically to throw so much confusion into Tesla's work and to absorb up all of the Tesla Society meetings and the psychotronic meetings and everything, and create this paranoia and fear, and then make money of selling devices to protect people against the non-existent waves. Because scalar means there's no wave. So if I say scalar wave, it's kind of like saying an Israeli-Palestinian. I mean, it's one or the other, you know. It can't exist. Scalar is that part that doesn't vary, that part in which there's no wave. That's why it's called scalar. It's a quantity with no direction in space or time. No divisions, no variation, no distribution. It's that part that's everywhere the same. A good example would be atmospheric pressure. Okay, if I take a barometer around this room and out in the street and all that, barometer always going to read, let's say, 30.1 inches. Doesn't matter there, here, any of that. Okay, I could take it up to Haight Street. I could take it down, you know, as long as I compensated for the altitude. You know, it's always going to be that air pressure wherever I go if I can maintain a certain altitude. That's space scalar. There's no variation in space. But if I graph the atmospheric pressure over a week, I get these like sine waves. So it's atmospheric pressure is scalar in space in the neighborhood. Obviously, if I go to, you know, Eureka, it's going to vary. But it's, in our area, it's scalar in space. But it has a wave in time. Does that give you kind of an idea what the word scalar means? It's that quantity that, it's like DC. If I take an electrical oscillating system and it's got impulses and it's got oscillations and alternating currents, there'll be one quantity of electricity that doesn't vary. While all the rest of it's going higher or lower in this way and that way, the one constant will be uniform throughout the whole circuit. That's the scalar quantity. So what Bearden did was use the trick to take, there's two types of waves. There's longitudinal and transverse. This is the whole bugaboo, and this is what the Einstein thing is disrupted. And this is the forgotten part of Maxwell's. Maxwell considered two types of waves. One is transverse. Okay, a transverse wave is like waves on the surface of the ocean. Okay, there has to be a boundary. And the motion of the matter or the ether or whatever deal you're dealing with is always at right angles to where the wave is going. Okay, and it's slowed. It tends to circulate and stay in one area and then move on to the next and move on to the next and move on to the next. That's called a transverse wave. In other words, the energy is sideways to where it's going. You understand what I'm saying there? Does everybody kind of get that? I guess? Okay. Now, a longitudinal wave If I set off a load of dynamite underneath the water, okay, and then another place underneath the water, okay, it's a shock wave, and that other place gets it real fast. There's hardly any delay at all. Okay, it's right there, and it'll blow your eardrums out. Okay, and the surface, initially, there's no evidence of this until the turmoil gets going. That's a longitudinal wave. Okay, the material or the energy or whatever is going the same direction that the propagation's going. It's in line. Okay, now if I take a 10-foot rebar piece, a half-inch rebar, okay, and set it on little deals so that, you know, it's free to kind of move around, doesn't fall to the floor or whatever, strings. Okay, what I can do is I can take one end of that rebar and hit it with my hand, and a little wave will whoop sideways, just like a transverse wave will go from one end to the other, right? I mean, that's like you do it with a piece of rope or string. The other way I can do it is I can hit the end of the bar with the hammer. You can't see that wave. It's instantly at the other end. That's the longitudinal wave. You see the difference?
What is a wave of compression?
It's a wave of compression and expansion.
The actual medium of transmission for delivering the
Right.
force, and the other is transverse, involves some other process.
Yeah, so it's a transverse wave is kind of operating out of the wave realm. It's not really a very effective wave. Now, if electricity is supposed to be transmitted through space electromagnetically, the first complication that comes to mind is where's the boundary? There is none. So Tesla said there were no transverse waves. It had to be longitudinal. So right there, then that kind of just messes everything up. You want to comment on that?
Yeah.
Sure. What are you thinking over there? What's that?
Electromagnetic propagation lies in those two, let's call them perpendicular.
Yeah, perpendicular, yeah.
And the effect of one is having an effect, or seems to have an effect on the other.
Well, the thing is with electricity is one aspect of it is denial of the other. Okay, well, here's what I'll do, is I'll take an electrostatic condenser, okay, a capacitor, Leyden jar, whatever, okay, and I put an electrostatic field in that, okay, and it's got its plus and minus, and this field's in there, and it wants to pull the pieces together, and all the regular stuff, but it can't do anything, okay, it's stuck. Now, if I take an electromagnetic inductance coil, which has a similar physical volume, but it has a complementary way of representing itself. In other words, the capacitor tends to work by dividing up the metal like this to get in between, where the coil does the dividing for enclosure of a space. Okay, now this device here, if I have current flowing through it, okay, it has a magnetic field. Okay, in order to have a current flowing through, of course, it has to be short-circuited. Okay, if I'm going to maintain this electrostatic energy, and so it doesn't go away, this has to be open-circuited. If I'm going to maintain the magnetic energy, it has to be short-circuited.
But each of them can.
Well, let me finish. Okay, so this represents energy storage. Okay, the energy being
kinetic.
Being the inductance. Remember we talked about inductance? Okay, inductance multiplied by the current squared. Okay, and that's in watt seconds. It's energy. Okay, it will light a 1 watt light bulb for 1 second. Okay, now the electrostatic energy is exactly analogous. It's the capacitance and the square of the electrostatic potential that's associated. So if I got 1 amp here, and I got 1 volt here, okay, and I have 1 farad here, and 1 Henry here, then I get 1 watt second. You see what I mean of energy. Okay, now if I take the capacitor, okay, and I take the coil, and the capacitor is full and the coil is empty. Okay, because now I've had a situation where, you see how these two things are conjugates, that one is the denial of the other?
It takes a lot of electric.
Well, let me just keep going. Okay?
If you ask how I see it, the inductor
Right.
requires a lot of electric potential stored up in the condenser to start a current flow.
Well, the thing is, we have the current flow.
Well, in the second picture, you have no current.
Well, I'm getting to that,
Oh,
exactly.
so it's empty. You said it's empty.
Yeah, the inductor,
It's waiting for
the
all that
inductor is
electric
empty, okay? The capacitor is full. Now I go like this. Now I have one is the denial of the other, okay? This thing cannot maintain a steady electrostatic field because it's shorted out by the inductor. But the inductor cannot maintain a steady magnetic field because it's open circuited by the capacitor. So the electricity is trapped, but it oscillates. So if I take the inductance and the capacity, that gives me 1 over the time squared of the oscillation. So we have these two aspects of electricity, and by themselves, nothing happens. Okay, but as soon as we combine them together, now we have an electric oscillation. And the electricity will continue to go back and forth for eternity until something takes away part of the field or something eats part of it up. So this is the electrical situation is based on this duality. Okay? It's called conjugates. If I have a glass of water, okay, and the liquid level is here, halfway up, not only is the glass half empty, but the glass is half full. And you can't have one without the other. It's a conjugate relationship. When I have an electromagnetic field, okay, and the magnetism is going this way, the electrostatic has to be going this way in an electromagnetic field. Now, in a Tesla field, it's completely different. In the Tesla field, the magnetic line's longitudinal. The magnetic lines of force and the magnetic lines of force operate in a line. Now, in this case, where the propagation of energy is at right angles to all of it, the propagation of energy is along the line. So this is a spatial situation, and this is like a counterspatial situation. This type of electric wave exists in a lot of electrical equipment. It exists in all your capacitor banks. It exists in all your transformer windings, your motor windings. Anything where the metal is divided up onto itself, you have these longitudinal waves. But they're, yeah, but they're not put into the calculations. Because the thing is, if you're designing a capacitor, you're designing it to be a capacitor. If you're designing a coil, you're designing it to be a coil, so you always eliminate the other field as being too small to be concerned with.
Because there's a huge one.
But what Tesla did is Tesla took the coil, okay, which has capacitance, okay, and what he did is he found this frequency where the capacitance of the coil itself matched the inductance to what's this called a resonant process. And at that point, the coil turns into this monopolar transformer. It's that simple. All you have to do is find the frequency of the coil of wire that if you connect it to the output of your radio transmitter, your alternator, or whatever, and the other end is grounded, okay, when you find the frequency where the energy of the magnetic field equals the energy of the electrostatic field in the coil, okay, this terminal doesn't have to be connected to anything. That coil, okay, terminated here. We have your alternator here and grounded. Now this coil will transmit into the ground without requiring another terminal. As long as that energy balance criteria is met, any solenoidal coil becomes a monopolar transmitter. Doesn't take any fancy equations or special turns, or obviously you can optimize it.
It's monopole because the other end is in the ground?
The other end's in counter space, inside the capacitance. If I want an electromagnetic waveguide, I have to have a boundary of metal conductors. That's why when you look up on the telephone pole, there's always a multiple of conductors, typically 3, to establish the boundary to confine the electromagnetic waves. But the problem with 3 wires and 3-phase is electricity is basically a 4-pole phenomenon. So now when you try to make it go 3-pole down the lines, not only do you have the transverse electromagnetic wave that we discussed, but the fact that there's no more plus and minus, but it's partially in between because it's a triangle now instead of a cross, is you have a longitudinal current going sideways between the wires. So the power flow down a three-phase power line is no longer electromagnetic, but is a complex electric spiral. And Steinmetz tried to crack this and backed off from it because it was a little too far for what was going on. And what this does is this triple wire configuration uses the least amount of metal to carry electricity from point A to B. Four-phase, four-wire, two-phase, two-wire takes more metal. For some reason, this triple phase, no one's ever been able to explain it, takes the least mass in your transformers, your motors, and your transmission lines. For some reason, the mass quantity in the electrical system has a low in that. And that'd be interesting to sit down and analyze that.
You mean for efficiency? That is four conductors.
Yeah, in other words, three wires will transmit the most electricity of any electromagnetic boundary phase type situation. You know,
Not
6
four.
wires, 4 wires, 2 wires, 3.
Not four.
It's got to be 3. See, the thing is these electrical pioneers, they got it to the point where this stuff was mathematically and what have you, it was there to work with, and then it stopped. So basically what needs to be done is to go back and pick up where these guys left off. What I did is the mathematics was never complete. The system of units was a mess. Okay, the physicists started putting 4 pi in the equations where 4 pi didn't belong. So what happened is then when you had your normal 2 pi, which always appears in almost all your alternating current stuff, the 1 over 4 pi c squared cancels it out, and it disappears out of your equations, and you lose the vision of the circle that you're working with. You can see what I'm saying. Cancels itself out. So what Heaviside did is he railed for what was called the rationalized system of units, to get rid of all the scales and the magnetic monopoles and the points of mass that can't possibly exist and the little gyroscopes and all the stuff that Maxwell just twirled the thing into the nth dimension with and make it into a basic, you know, A plus B equals C type of situation. Was to get rid of all the complexity. So let's see, anybody else got any other, looks like we're about petering out here. Yeah.
Maybe you can go over the integratron real briefly.
Okay, well the integratron is, that is what I regard would be the physical manifestation of the scalar transmission. In other words, that's the device that if you have one on Mars and you have one on Earth, if you go in the one, you walk out of the other. That's, when I studied that.
Was there one of those in Lancaster?
No, there's none of them around anywhere, really. About the time I figured out how to make it all work and found that all the materials were there and the whole thing was kind of set up like a Heath kit, and I managed to get all the junk and the weirdos and everything out of there and all that, well, lo and behold, the guy that had the property lost it and everything disappeared. So
George made a really great comment. I thought it was brilliant notes. He was talking on the phone one night and he said, you know, Charles, this reminds me of Carl Sagan's Cosmos. The exact same story.
Contact.
Contact, I'm sorry.
Contact.
Excuse me, Contact. Same exact idea. Eccentric billionaire funds this project. Guy in desert gets these plans from somewhere, and it was really meant to be a portal.
Rotating device.
The rotating device, exactly. Which I thought was a great listening.
With Tesla.
Because I actually met Carl Sagan once very briefly, and I got the impression this was a very bright guy. He was also very confined, and he was being extremely careful about what he could talk about or not talk about in this very broad realm that he was communicating to the outside world. So I thought it was interesting insight, but maybe share.
well, this thing about the integratron is my theory. Okay, I mean, I didn't, you know, I've never built anything where you walk in the one box and you walk out of the other one. But the thing is what I found is this integratron structure had to be space scalar. If you analyze the electric fields that appear, the key to the integratron was it had a pair of coils, 90 turns, and 1 mile of wire on the ceiling of the first floor. One went one way in copper, and the other one went the, got this right? Yeah, the other way in iron. 10 gauge copper, 14 gauge iron, soft iron wire, all insulated. Okay, and there's 4 spark gaps that were remote controllable by compressed air and plastic pipes. So you couldn't have any metal in here to short this thing out. The whole thing was charged up with 100,000 volts from the thing that spins on the outside. Electrostatic generator, and the dome is covered with metal, so that's your capacitor to space. And this thing is inside the flux underneath, and these spark gaps fire into the copper and iron, which juncture in the middle. They fire, two of them fire into the ends of the coil, and two of them fire, I forget the exact diagram, but two of them fire into the dome. And so it's this electrostatic energy is being pulsed into this coil. Okay, where they come together in the middle, there's kind of like a capacitor and a column. They drop things down. And what goes in there, I don't know. But when you analyze this, what it comes out to be is it's a strictly space function. There's no space variation. So what I did is I did some experiments, because Van Tassel was always talking about caduceus coils. That's a coil where you got turns one way, and then compounded on it is turns the other way. And what I found is, if this is coil A, I might have it wrong, but from the outside it'll look right. This is coil B. Okay, if I connect them in this way, okay, at these terminals, because this thing will resonate in an inductance capacitance oscillation, but the amount of capacitance, the amount of inductance here is all screwed up by the fact the turns are wound backwards on each other. This thing will oscillate at a frequency of roughly 100 times beyond the wavelength of the wire, and with a precision that's so intense it makes you wonder, like, what's it locked into? And somebody had tried this idea and came up with some UHF TV antennas built on this principle, and the receiving range apparently is fantastic. So this is the key to the integratron, is to create this space scalar condition, where it exists only in time and it doesn't exist in space. And that started to give me the idea that maybe this thing wasn't for healing people, but for making people be able to go from point A to point B. And then the Alexanderson space scalar concept popped up later in my study of RCA, and so that kind of serves as, again, as an analog to this space scalar situation. So if somebody wants to start experimenting with, building a transporter, it's not a matter of taking the molecules apart and making them reappear at another end. That would be a hideous project. Doesn't make any sense. The best thing to do is just simply erase space out of the formula so that you're both places at the same time, and then make the switch. Turn one off and leave the other on. That's how I perceive the integratron. Allegedly, how many people here know what the integratron is or heard of it? Okay, well here's the integratron for the people that don't know. Okay, there was an old German guy that lived under a rock out in the desert. Okay, and it used to be a place where things would appear in the sky. It's called Giant Rock. It was a giant rock. Old German guy lived under it. It was in San Bernardino County. Okay, this was during World War II. Okay, the German guy had a big shortwave antenna, and his, Atwood Kent, with all the tube radios and all that. So for some reason, the Riverside County Sheriff's Department decided that he was a German spy, and they killed him, blew him up in his hole. Well, Van Tassel had been coming out to visit this guy to hang out, because that's the place to see the weird stuff that flies around in the sky at night. So Van Tassel just inherited the place because he was there and nobody else was, and it was the deep desert. And he was an aerospace worker for Howard Hughes on a personal level. So he was into the whole kind of, spacecraft and all these. Because Hughes came up with some really bizarre stuff you don't normally hear about. That's probably why he was put out of business. Hughes was deep into this stuff, experimenting and what have you. He was a genius of his own right. So apparently Van Tassel and his son-in-law were approached by a spacecraft. Okay, and the aliens gave them instructions to build this integratron device. And they went forth and started building it, and started having these conventions, and turned the whole thing into a dog and pony show. So the space people cut them off. So they carried on the dog and pony show until eventually everybody kind of died off, and that was the end of that. And then the geeks ended up with it. So you had the Purple Gay Indian Club, and then you had the bikers, and I don't know how much meth might have been cooked there in various phases. It looked like it might have been a lot of LSD. So my job as the exorcist, that's one of my positions in life, is I go in and I run the devils out. So without a shot being fired, I got rid of all of it. And then once all the junk was gone, and I was introduced to all the people that knew Van Tassel, and I read everything he wrote, I went around and found all the little pieces here and there. I found once the mess was cleaned up, here was a Heath kit. The boxes of wire, the aluminum for the dome, it was all lined up right there on the floor, ready to go.
That's Big Rock right there.
Giant rock.
Giant rock, yeah.
So what I did is start to put it together, and with 6 months, gee, I wasn't there anymore. All the equipment disappeared.
And they filled in with concrete as well. They made sure.
Well, no, the dome is still, this has been, yeah, the
exactly.
Park Service, there's no more under the rock.
Right.
And then the rock split in half. I think that's what you're seeing there as the piece broke off.
That's right.
So we decided we were going to plant some rumors around there that there was some people buried under the rock and name it after the people that didn't really exist.
Yeah.
Something derogatory, because that place now is just a haven for motorcycles and I haven't been there in 20 years. You can't see the stars out there anymore anyway. So that's basically what the Integratron was about. So now these people have it under lockdown, just like they have the Bellina station under lockdown, everything else under lockdown. And it's just become another self-worship temple. So that's the end of the Integratron. But that doesn't stop people from building models and experimenting with this stuff.
How are you spelling that, Integratron?
Oh, I'm not good at spelling things off the top of my head.
I-N-T-E-G-R-I-T-R-O-N.
Like it sounds.
There's a website, integratron.com.
Yeah, the website is the enemy.
There's also a retro UFO thing coming up in July or something. I'm not sure when it is. There's some event there.
You can find the website on KPH, the station in Belenis, too, and you can see all the people that are responsible for screwing all my stuff up. Because basically all their website is pictures of themselves standing in front of equipment.
That's the Integratron.
So you can find the most compromising picture you want for your voodoo festival. I encourage you to experiment. You couldn't find a better group.
Speaking of experiment, you flailed a cord or something about through a magnetic field and counted like different speeds.
No, what I did is I took a relay coil, which had about 1,000 turns of wire in it.
Very good.
So it could absorb up the magnetism to the point where it would drive the headphones. It had a magnetron magnet. I took the coil and moved it around the magnet, and I could hear the magnetic field scraping through the coil.
There would be
Scratching noise.
Okay, so
The lines of force.
which you interpreted as like real sharp transients, saying this is not a smooth continuum.
No,
These
it's
are really
fibrous.
Sharp boundaries.
It's fibrous.
You could do that again, probably.
Anybody could do it.
So that would make a great introductory class lab.
Anybody can, that's the whole thing, is to experiment. What I did is, I didn't have any, college professor or anything. I was just a kid. Main thing I wanted to see was big sparks. So how's the little 6-year-old junior going to get big sparks? So, it's a different way of studying when you're a kid. You're going after more, I don't know, you're better off that way because there's no preconceived notions. That's why Tesla and all these people could make these discoveries, because the mind viruses weren't established yet. They could move freely. There was no unit of the Henry and there was no unit of the Farad when Tesla built his Colorado Springs project that had just been developed. So when you read these guys' books, you have to go use their system of units, CGS system of units. The volt and amp, see, all those things are all recent ideas. But the original guys weren't hampered down with all these definitions like now. They were able to move freely in it before it became rigidified as a corpse, like electrical engineering has become today.
We're at 6 o'clock.
Okay. I'm spent. I think everybody's got a brain full.